Hello everyone, welcome back to my YouTube channel Cloud and AI Analytics. Hope everyone is doing good. I am Vignesh and in this video we will be discussing one of the SQL service offered by Google Cloud platform called Cloud Spanner. So in this video we will be discussing how to create a Cloud Spanner instance through console, and then we will discuss a small use case where we'll be creating a database everything through console, and then we will create two tables and we will discuss the interleaved table. So what is interleaved table and how that concept particular interleaved table will be applicable to this use case scenario which we are going to explore. And then finally we will delete the database and then delete that instance. So without any further delay, let's get started. So I am inside my cloud console, and here you can just click on this navigation menu, products and solution, all products under databases. You will be able to find the spanner. So two SQL databases, one is Cloud SQL itself and the next one is Spanner, Cloud Spanner. So you have to just click on this spanner. The first thing is you have to make sure that you have enabled the API. So in the free trial, we'll be not able to explore the actual power of Cloud Spanner. Instead, there will be certain limitations. So here you can see Spanner is a fully managed relational database that offers transactional consistency and high availability at a global scale. The limitation, what you will be seeing in this Cloud Spanner's free trial instances, you will be not able to take a backup of that data. So first just click on this create a provisioned instance and this will open you the screen. So here you can see you can create an instance. So name of your instance, you can just give demo GCP and underscore 001. So an instance name has a both name and an ID. The name is for display purpose only. The ID is permanent and unique identifier. So here you can see this is my instance name demo GCP 001, and instance ID, like I can't give underscore under, it will not accept. So basically it will not accept the underscore. So I'll just give hyphen and I'll just move on. So this is my instance name. If I want to edit, I'll be able to edit it even after creating the instance, but the instance ID, I'll be not able to edit it. So the next thing is you can choose a configuration. So determines where your node and data are located. So when you're going to create an instance, this particular, whether it is a regional or multi-region, this determines where our data and the node, that is our compute, will be stored. So it affects cost, performance and replication as well. So this is a very critical when you are going to create a spanner instance. So this spanner instance, like the region or the multi-region, it is depending on the use case which we are actually working on. Based on that, you have to create whether you are going to create a multi-region or regional instance. So based on this only, your replication, cost and performance, everything will be decided. So a multi-region configuration will select the default leader region for your leader replicas. You can change your leader region at any time with a DDL statement. So first you can just click on this compare region configuration. Since I am very close to Mumbai or Delhi, I'll be creating this Mumbai, and the next region I'll go with US East to 4. So this is just for comparison. You can see what's the location, what's the configuration type and what are the replicas. You can have 3 rewrite replicas in 3 separate zones within the region. And here it is also same, 3 rewrite replicas in 3 separate zones. And available optional read-only replicas. This is available only for multi-regional instance. The availability is both are same. The compute cost, here you can see that is $1.26 per hour when I choose this particular region, and this is $0.99 per hour when I choose this region. So the storage cost also, it is $0.42 per GP per month, and it is $0.33 per GP per month. So from this we can clearly see that US East 4 has minimum cost on compute under storage. So if you want to compare it with multi-region also, you can go yes. So till this we have seen only the regional, Asia East 1, Asia East 2, and from here you can see multi-region. So Asia 1, European 3, European 5, European 6. So first, for example, I'll just take this London, Belgium and Netherlands. So I'm just going to compare region with multi-region. So here you can see the location is Mumbai. Here it is London, Belgium and Netherlands. And configuration type regional, multi-region. So here you can see 3 rewrite replicas, but here it is 2 rewrite replicas in Europe West, default leader region. So this is the default region London. If you want, you can change it after creating the instance with the help of DDL statements. So 2 rewrite replicas in Europe West 1 and 1 witness replica in Europe West 4, that is Netherlands. So here you can see availability, compute cost and storage cost. I am just going to select it as multi-region, and that multi-region is going to be Asia 1, like Tokyo, Osaka and Seoul. So I'll just create a multi-region, and here you can see the configuration. Asia 1, the regions which is included as part of Asia 1, and replicas. To rewrite replicas in Asia Northeast 1, Tokyo, that is the default leader region, and 2 rewrite replicas in Asia Northeast 2, that is Osaka, and 1 witness replica in Asia Northeast 3. And availability is 99.999%, and the maximum storage capacity is 4 terabytes. And here you can see the compute cost and the storage cost. So compute cost is $3.90 per hour, and storage cost is $0.65 per GP per month. And here you can see allocate compute capacity. So based on your requirement, you will be able to have one compute capacity or one nodes, 100 nodes, all those things. So like processing units and nodes. Like processing units, it will come in 1000. So processing units and nodes. So basically you can have nodes in 1 nodes, 2 nodes, 3 nodes. So basically those things, but minimum is 1. So processing units and nodes. Your compute capacity determines the amount of data throughput, queries per second, and storage limited in your instance. One node equals 1000 processing units. So when you go with nodes, it is like 1000 processing units. When you go with processing units, you can increment it to 100 like or thousands. So either increment of 100 up to 1000 followed by increments of 1000. So till 1000 you can increment it to 900 and all, but after 1000 it should be increment by 2000, like 1 node, 2 node, 3 node, those things. So we are go with nodes, and we'll have 2 nodes. One node equal to 1000 processing units, and here you can see the compute cost has increased $7.8 per hour, and storage cost also increased $0.65 per GP per month. So this is how you will be able to create the instance. Here you can find how to some guidance on how to configure your compute capacity. Now I'm going to create that cluster. Unlike Cloud SQL, it will not take like 7-8 minutes to create an instance. This is very fast. Within a fraction of like less than a minute, you will be able to create that instance. So I'll go to this all instance, and I'll show you how it is, like whether our instance is ready or not. So here you can see demo GCP 001 and ID, configuration, processing units, nodes, storage, labels, tags, all those things. I'll just go inside it, and here you can see name, ID, configuration, what is the compute capacity, processing units is 2000 and nodes is 2. Basically one node equal to 1000 processing unit. And CPU utilization, operations, read and write, throughput, all those things you will be able to find it. The first thing is we are going to create a database. I'll get into that later, but before that I'll just show you what all the presence inside this Spanner instance. So this is the overview. And import and export. If you want to import, if you want to export, basically you can do it with the help of Cloud Data Flow. You will be not able to export directly to Cloud Storage Bucket or directly to any other GCP services. You will be able to export only through Cloud Data Flow, and that only we'll be able to use Cloud Storage Buckets only. Either you will be able to import or export from Cloud Storage or to Cloud Storage Bucket. At end of this lab, I'll show you how to export the data, whatever the data which we have. I'll show you how to export that data to Cloud Storage Bucket. And this is backup and restore. In free trial, you will be not able to do it like up to that instance, but a small things you will be able to do it. And then the observability, like system insights, basically what is the utilization. You will be able to see everything inside this Google Cloud, inside this monitoring itself. Here you can see the recommended maximum per instance is 45%. Since it is a multi-region, the recommended itself it's 45%, and you can find all the other details as well. And then the query insights, like how many queries we executed on what databases, you will be able to get all the details there. And log insights and transactional insights. So first we will go to this overview. Instance has been created. I'll just create a database. So my database is hospital_db. So this is my database, and select database dialect. So you can use this Google Standard SQL or PostgreSQL. When you go with Google Standard SQL, it will be very similar to what we use in like SQL Server, like the same query which we use in BigQuery or Cloud SQL, those things which minimal changes here and there. So Google Standard SQL. The next one is PostgreSQL. So I'll go with Google Standard SQL, and here you can see this is given by Google Cloud itself, like sample detail statements, how to alter the database, how to create a table, alter a table, drop my table, index, all those things you will be able to see it here. And the next one is schema and data model. So here you can see primary keys, table interleaving. This is the concept which we will be seeing here. And the next one is schema updates. If you want to update the schema, the one important thing you have to understand when we are working with Cloud Spanner is you will be able to update that schema at the runtime itself. Without editing the instance itself, you will be able to update that schema and with zero downtime. So that is the one important point you have to understand when you work with Cloud Spanner. But the same thing, if you want to do it in Cloud SQL, you have to edit that instance. That will again take some time. So this is the main difference, not main difference I would say, but one of the difference between Cloud SQL and Cloud Spanner. And then the data types. What are the different data types available for Cloud Spanner? And cloud data types, and here you can see fine-grained access control, the same thing which we discussed in cloud storage buckets as well. Like in cloud storage bucket also we have uniform and fine-grained as well. So if you want, you can give that IAM roles based on the fine-grained as well at the table level or at the database level as well. It is not mandatory that you have to give restrictions or you will be able to give roles at the instance level. You will be able to restrict at the database level or at the table level as well. And here are some best practices. We'll be discussing about this in upcoming sessions in this particular playlist itself. So the first thing is I'm going to use this DDL templates and you can create table, create index, create view, create change stream, and edit table schema, update database option, database role, Vertex AI integration. The reason why Spanner is integrated, like we need to integrate Spanner with Vertex AI is because in Spanner, like the minimum requirement is 2 terabytes of data. If we have that much of data, that will be really helpful for us to build our AI ML model. So that is the reason why we have this Vertex AI integration. So first I'm going to create table. So here you can see create table, column name, and the primary key. What is the primary key for this table? So I'm going to show you this. So I'm going to create a table called patient, P-A-T-I-E-N-T, and this have 2 IDs, patient ID, patient name, and primary key is my patient ID. I'll copy this and I'll execute it here. So I just copied it, and if you want encryption option like Google Manage or Customer Manage encryption, you can do it. I'll just click on this create. It will create a table for me. So yeah, the table is also created. Table name is patient. You can just click on this patient table and you will be able to see what is the column, what is the primary key, what is the type, nullable, order, what's to buy. You can see all those things. And if you want to add interleaved tables, this is the important topic which we are going to see. I'll show you here. So if you want to write a DDL statement, you can just click on this write DDL. Once we are inside the database, so we are inside the database, you can see a query has been added, a new window has been added. So here you can execute the queries directly. So the next one is I'm going to create table. So create table appointment. I'll just execute it and I'll let you know what is the establishment. So create table, appointment, and here is appointment ID, patient ID, physician, primary key is patient ID and appointment ID, interleave in parent table, that is patient, on delete cascade. I'll explain you what it is. Before that, I'll just execute this. So here you can see the table has been created, appointment. So appointment table is the parent table for patient. So if I just click on this appointment, you will be able to see what all the parameters like column, type, and here you can see the physician and nullable, all those things. And before proceeding further, I just wanted to explain what is this two table, how it is related with each other. So here you can see create table patient, patient ID, patient name, and the primary key is patient ID. For example, like just assume a scenario where like the patients will schedule the appointment with the doctor to consult the doctors based on their patient day has to schedule an appointment with a doctor. You can basically schedule it, and that is how the actual scenario works in the real time as well. So the create table patient and the appointment table as appointment ID and patient ID and physician, which is the doctor. So the appointment and patient are the two tables. Like patient is the parent table and appointment is the child table, and like patient ID is common across the two table, and this is where this patient ID will establish the relationship between this two table, that this patient is going to have an appointment on this day, whatever the day is. Like we are not going to in depth in details, but he is going to have an appointment on this particular doctor, that is this physicians. So interleave in parent patient on delete cascade. So like interleaved table means you want the row of the child table to be physically stored with the associated parent row. So this is the child table. whatever the table whatever the record which is present inside this table, it is going to be physically associated and stored according to this patient table, that is the parent table. Here if you see interleave in parent patient on delete cascade, like if the record is removed from this patient table, the record is removed from that primary, that is the patient table, then automatically associated record will be removed from that appointment table. You can directly remove this, execute a delete statement here, and this will remove the record also. So that is what we will be seeing here in the use case part. So on delete cascade, annotation signifies that when a row from the parent table is deleted, its child row are automatically deleted as well. So that is what we will be seeing in the scenario as well. Interleaved rows are ordered first by rows of the parent table, then by contiguous rows of the child table that shares the parent's primary key. I'm again back into my console. I hope the use case it's very simple and you understood it. First, for now, we'll go to this query. So inside this query, what I'm going to do is, like, we created two table, patient and appointment. Till this we have completed it. Now we are going to insert the records inside patient table. I'm inside this hospital database. This is my database. Here you can see the database name, the database dialect, encryption type, schema update, all those things you will be able to see it here. If you want, you can create table. This will again take you there, or else if you want, you can write a DDL as well. So you can, if you want, you can write a DDL. So I just clicked on that write DDL, and here you can see create table. You can go back to this screen again. Now if you want to execute query, you can just come here, you can just click on this query, you will be able to see a screen like this. Yeah, this is what we are going to insert, like insert patient, that is the table name, patient ID, patient name is the value, column name, and the values is patient ID, patient name. So all those things, and I'm just going to, here you can see the valid is, like our SQL query is correct, we can just execute run, and you will be able to see 5 rows inserted. Now if you wanted to cross check, like you can use this select star from patient, and you can just execute it, you will be able to see the records here. So patient ID and patient name, and in the schema you can find all those details. Like we have two tables, one is appointment, the other one is patient. So patient ID, patient name, and patient ID, appointment ID, and physician, this is inherited. Like with the help of patient ID, we are establishing a relationship as well. So you can see their schema and the explanation as well, like how it got executed, all those things you will be able to see it here. We'll get into this later part of this particular playlist. I'm going to insert records into my appointment table. So this is the record, like insert appointment, appointment ID, patient ID, and physician. So here you can see 100 is my appointment ID, 1 is the patient ID, and physician name is this. So here if you see, we are going to insert the record inside this appointment table. So I'll just going to execute insert appointment, appointment ID, patient ID, and physician. I'm just going to execute this. So the 3 records has been inserted, and I'm going to execute this as well. Like select star from appointment 1, like 100. Like here you can see I have created one more table called appointment 1. The same query, the same whatever we have created an appointment, the just replica of the same thing, but appointment 1. So we are going to use patient and appointment 1 here. So I'll use select star from patient, and here you will be able to see the records. And now what I'm going to do is I'm going to delete this particular record 3. So what is the third one, like the patient ID 3 with the appointment table? I'm just going to execute this, and here you can see appointment ID, the 3 is marked. So we are going to delete this particular record. So what I'm going to do is I'm going to execute a statement called delete from the table name, delete from patient, where patient ID is 3. So after executing this, you will be able to see one record has been deleted. So by this we should not get that 103 mark. So that should not be present. Here you can see 100, 103, and the mark is been removed. Select star from patient, you can't see that Swati 3 has been removed, and whatever associated to that particular physician, that is also removed inside this appointment table. So this is what we'll be using, this interleaved table on delete cascade. The other option is interleaved table on delete nothing as well. Like there is another which we'll be seeing in the other part of the video. Select s dot patient name, a dot physician from patient, as like you're just doing a join here. So select yes. Yes is the patient table and A is the appointment table. And if I execute this query, you will be able to see patient name. So I have to use the appointment 1 table, not the appointment table. So here you can see patient name is Vignesh and physician is Neetu, and this is how you will be able to establish that joint, inner joint, left joint, right joint, all those things also you will be able to do. If you want to delete the database, you can just click here, delete the database basically. And so that's it for this video. I hope you learned. If you have any questions, post that in the comment section. I'll take a look at it and reply to it as soon as possible. Please do like, comment, share and subscribe to Cloud and AI Analytics. Happy learning.